number 3, aging strategy and using futures. So first of all, we're going to see the difference between long and short aging. So actually the only difference between both are what is for selling and what is for buying. The long future aging is appropriate when you know that you will purchase. In fact, the main goal is to minimize the risk of the future prices to keep the same. So some people in the book they say that one of the advantages is it's everyone can do it. It's really easy, but it's as I always say, it's keep the risk. It's minimize the risk against the future interest rate and exchange rate and other market variables. The argument against aging is that shareholder can have their own share aging, which make kind of bad thing for the company, because when you can already have an influence on the price, it can be really bad. But as we know that share, we can make decision with share, and it can have an impact on it. It increases the risk of aging when the competitors do not. So I'm going to explain why. Imagine that I am a producer and I sell gold, and I am the only one who blocked the price. So of the future price. So it can be bad, because imagine if my competitor didn't do, the price can fall and they can sell for cheaper. So I'm gonna lose many clients because they are not going to be in my jewelry, for example, because I'm too expensive, because I blocked the future price. Because of the aging. So in that reason, it can be a bad thing. Do you understand what I'm saying? Is true or not? I don't know. Do you understand? No? No? Okay, I continue. So basic risk, we have to know the basic risk. We have to do a difference between spot and price minus the future price, and after that, basic risk arise because of the uncertainty about the basic when the agent is closed. So we can see only the basic risk when we see the future prices. So long ages for purchase for an asset. So now we can see that we have different figures. Yeah, we have F1, F2, S2 and B2. So as we say, the gain future is F2 minus S1, and then you can read, I think, the net amount paid. The difference when you have 2 times the time ones minus the time twos, and it's explained, I think, but okay. So that is for long, and this is the difference with the short one. The only difference is it's F1 minus F2, and the first one you can see that's F2 minus F1. So it's only the difference that I check, and then S2 plus, and on the other one it's S minus. So yes, okay. How we can choose a contract? So choose a contract when you're a company is really important. You have to check the delivery month that is as close as possible to, but later than the end of the life of the ages. After that, we say that when there is no future contract on the asset being hedging, choose the contract whose future price is not hedging correlated with the asset price. This is no cross hedging. So it's in the book they gave us 2 examples about that. We have to take care about the delivery month. This is really important, because if we receive in fact the real goods. It can be bad for the production in reality if we do the okay, I don't know. Sorry for my English, it's kind of weird. After that, they give us the optimal edges ratio. As we can see, there is a formula here. So how to read that in French? So proportion to exposure that should optimal be edges is, and then you can see the equation. Exactly the same thing for the optimal number of contracts. We have optimal number of contracts is telling absumment. So after that we have optimal number of contracts after telling adjustment to allow or delay settlement of future. And they give us an example. Airline will purchase 2 million gallons of jet fuel on 1 month, and engine uses heating all in future. So they give us already the sigma f, and then we just have to compute. So it's basically this formula that we saw already. Sorry. Okay. So after they give us another example that you can find in the book. So the size of 118 oil contract is 42,000 gallons. The spot price is 1.94, and the future price is 1.99. So they make I don't know the verb in English. Okay, I'm sorry, I don't know how to say that in English, but you can see 0.77 is what we calculate before. It's there. Sorry, it's here. It's first they made a calculation about the optimal aging ratio, and then we reuse it in the first compute here for I don't know in English. Sorry, 2000 divided 42,000. C'est une catastrophe. I'm sorry, like I don't know in English to explain the calculation, so comment dire? T'es sûr que c'est multiplié? Okay, but anyway, I continue. Aging using index in future. So the aging the risk in a portfolio, the number of contracts that should be shorted is, and we have the calculation. Where VA is the value of the portfolio, B is the beta, and FV is the value on one future contract. After that, this example, it's already in the book, so I didn't. Do I have to? Excuse me. Do I have to do it? It's on the book already. So you can find. Maybe you need the page. Page 63, you have all the computing of this exercise. So why aging equity returns? You may want to be out of the market for a while. Aging avoids the cost of selling and repurchasing the portfolio. And suppose the stock in your portfolio have an average of beta of 1 1.0, but you feel they have been chosen well and you will outperform the market in both good at the bad time. Hedging ensure that the return you earn in the risk-free return plus the excess return on the portfolio over the market. So stack and roll it. We can roll the future contract forward to hedges future exposures. Initially, we enter into future contract to hedging exposure up to the time horizon. Just before the maturity, you choose them out and replace them with the new contract reflect the new exposure. Liquidity issue. So in any hedging situation, there is a danger that losses will be realized on the hedges, while the gain on the underlying explore are unrealized. They can create liquidity problem. One of the example is Metageliscraft, which sold long-term fixed price contract on the heating oil and gasoline and hedging using stack and roll the price out of so I think in conclusion of this chapter number 3, we can see that hedging, even if it looks great, because you can block the price and you can see that it covers the risk. It can be also really bad because you can lose a lot of money and you can win also a lot of money. So the company have to take care before doing this kind of hedging. So thank you for your attention.
Very simple situation. A stock price is currently $20. In 3 months, a quarter of the year after, we have 2 cases. A stock price can go up to $22, or stock price can go down to $18. Okay, so basically we have 2 scenarios. Okay, go up, go down. Of course, in reality, there are infinite number of possibilities, but that doesn't matter. Once we understand this, there is a slight technical extension. Okay, that's nothing. In addition, you may wonder where these numbers come from, this and this. It is also very easy to estimate that, so you don't have to worry about either. Okay, everything is straightforward. So anyway, we have 2 scenarios. Stock price can go up or go down, and then we can now introduce a simple derivative such that in the first scenario, the derivative pays $1. In second scenario, the derivative pays nothing. Okay, so it is basically betting on the scenario. Okay, betting on the state. Pay $1 here, pay $2 here. And our question is, if there is a contract that pays $1, the good scenario, kind of good scenario, right? Stock price go. And what is the value of that contract? $1? Why? So you think the option price $1. So the value of a contract that pays $1 in good scenario is $1, right? I have the same question. Okay, what if the probability of this situation is very low? Do you still want to pay $1 for this contract? Then why? Beg your pardon? Yes. So the best scenario. Let's think about your answer for the time being. Okay. The best possible scenario from this contract is get $1. The worst scenario is get nothing. Therefore, you don't have any reason to pay $1 to buy this contract, right? Because there is if the probability of this scenario is greater than 1, your expected payoff is definitely lower than $1. So you don't want to pay $1 for this contract. So intuitively, the value of a contract should be less than $1. Right? Another reason is that there is a time gap. It is a future money. you don't wanna pay exactly the same amount for future months, right? So again, therefore this should be less than $1. Another intuition is that the value of this contract should be greater than 0, right? Why? Why? Why the value of that contract should be greater than 0? Not complicated at all. You don't ignore stock price just for that answer. Okay? Again, in scenario 1, first scenario, you receive $1. In the second scenario, you receive nothing. So what is the worst case? In the worst case, you can receive anything. So at least you don't lose money. Right? There is always a positive probability of getting money. Therefore, the value of a contract should be greater than 0. Right? Because there is no possibility, there is strict possibility that you receive money, right? And no possibility of losing money. This is a good contract, so therefore, in order to obtain this contract, you have to pay money. Right? So, intuitively, the value of this contract should be 0 to 1, between 0 and 1. But we want specific number, okay? What is the exact value of contract? Actually, about your answer, we can actually narrow down. Okay, we can narrow down the range from 0 to 1. We can slightly narrow down. So, okay, in this contract, we receive $1 only in good scenario. Let's think about better contract. In the better contract, we receive $1 here, and suppose another contract that is $1 here. So, in this contract, let's assume a contract that pays $1 in every case. Then what would be the value of this contract? Yes, so you receive $1 for sure in 3 months, right? Therefore, the value of the contract is discount. Right? You discount that $1 to the interest rate, whatever interest rate it is. So if the interest rate is R, interest rate is annual interest rate is R. Why I hold yellow chokes? Okay. So let's say interest rate is R, and timing between today to the cash flow is delta T. Okay, here it is 3 months, right? So in this case, if we receive $1 for sure in 3 months, therefore it is 0.5 in annual. Okay, therefore the value should be 1 minus R delta T, right? If it is, you know E, right? Does everyone knows exponential E? Do you know that? This one? Did you run that? Yeah, this number. Do you know what it is? No, how about you? Ah, man. Okay, let's talk about this one first. This is the most important number in finance. Okay? How about you? Do you know the E, right? Please raise your hand. It is okay. Please raise your hand if you didn't run that E. Okay. Okay. If you forced to never heard about E, that's fine. It's very easy. It's nothing. E equals mathematical constant or Euler constant. The definition of E is simple. E is sum of 1 plus 1 plus 1 2 1. This is the definition. What? How you think you know? But there are other things you don't know. How about you without using formula? this is E. This is a mathematical definition of E. And actually we use more of this one, EX. Otherwise, my lecture is not recorded. So, okay, EX. EX. E to the power of X. The definition of EX is simply you put X over here. X square, X third, so X power of N. Okay, that's definition of E. Definition of E is EX is simply infinity and factorial. Okay, this is the mathematical definition of E. And then this is definition, and it is a very interesting property. Interesting property that derivative of this one is itself. Because, okay, let's take a derivative of this one. Okay. And EX is, it is a 1 plus, okay, 1 factorial 2 factorial x squared, 3 factorial x third, right? So if we take derivative, then this is 0 plus this is 1, and this is 2 in front of it, cancels, so 1 factorial x, 2 minus 1, so which is 1, plus 3 right? So cancel, so 2, so this is 2, right? So therefore, now this one is same to this one, and this one is same to this one, and this one is same to this one, right? Therefore, the very interesting property of EX is that if we take a derivative of E, then it is itself. F prime x is simply fx. That's a very convenient property. And it is mathematical definition, original definition, but in finance, we use the definition of this one more. Okay? Yes. In finance, this is our preferred definition. Okay, in finance, instead of using this one, 분필이 없나? 잠깐만요, 하나 있네. In finance, our preferred definition is 1 plus n x and goes infinity. That is our preferred definition. This is our preferred definition. It is our preferred definition because that is called continuous compounding in finance. Right? That is called continuous compounding. Then what is continuous compounding? I don't want to use chalk. Let's use graph. So, continuous compounding. Continuous interest, continuous compounding definition, continuous compounding interest formula. Compound interest. No. Why there is no compound? Math is fun. Okay, this is compounding interest, right? This is present dollar, okay? Present value of money. If R is interest rate, and then N is number of periods, then future value is simply this one, right? This is called compounding interest rate, okay? And then our question is, what if we divide interest rate for some period and compound it over that some period? So suppose interest rate is R, okay? Interest rate is R, okay? Interest rate is R, and suppose we divide that interest rate over n some period. So if interest rate is 12% per year, and if semi-annual compounding, in semi-annual compounding contract, I pay 6% per 6 months. So then 2 times per year over compounding. Okay. So if it is 1 year interest, it is simply 1 plus R. And if it is semi-annual compounding, it is 1 plus 2 R over 2. So some period 2 times per year. So I pay half interest rate for every 6 months, and it is 2 times, so compounding 2. Right? And how about usual bank contract? In bank contract, it is monthly, right? Monthly. If it is the annual interest rate is 12%, they pay 1% every month, and 12 times per year. In that case, it is 1 plus 12 are 12, right? And we can be more extreme. How about daily compounding, right? And it is 365 days per year, which means that we pay small interest rate every day, and then compounding every day 365 times, right? And it is, of course, looks like 1 plus right? It is compounding is more frequent, right? In most, we can pay, but we can be like hourly compounding is also possible, right? Theoretically, so hourly compounding we can pay simply 24, right? Because 24 hours a day. Therefore, in annual compounding, looks like this. This one seems that this number and this number becomes bigger and bigger. We can be more extreme, like minute compounding or even second compounding. And if we become infinitely small sub period, then this becomes very big number. Then this one looks exactly like this one. Right? So this one converted to this one. Therefore, this one, by the definition of EX, this one will convert to E to the power of R. Right? That's why E is fundamentally important in finance. Okay? And then, of course, if it is over several years, then simply we can multiply T. Right? Over several years, then it becomes ER to the power of T. ERT, right? So something like this. And then if we discount it, then we have to divide it. So we put minus over here, right? So E is fundamentally important, the most important number in finance. And then for your curiosity, okay, E looks like this. The value of E to the power of 1 is 2.71828 blah blah blah. Okay, and it is irrational number. So there is no pattern over this number. It's irrational number. There are other ways to define E. Looks like this. It is alternative definition. And then derivative of e with respect to ex with respect to x is same. Okay. And then when we usually say log is this one. When a is e, it is simply log. Okay. From now on, when we say log, we consider basis. Base is e. Okay. Here the a is e. Natural log. Whenever we use log, we assume we are using natural log. In high school, when we learn log, the base is 10, right? But in university, when you say log, the base is e. Okay, this one. Okay, so therefore e, because log function is inverse function of a power function, therefore e to the power of log x is simply x. Right? Because it f inverse x, right? So the natural logarithm number is logarithm to the base e, where e is irrational, transcendental constant approximately equal to that number. And in Excel, so first, just one compounding, interest rate is 4%. Therefore, 1 year after it is 1.04, right? That's what we learned. How about second? Two compounding. Okay, so it means we pay this means annual interest rate is 4%. Therefore, now we pay 2% every 6 months, and compounding it 2 times. That number to be approximately about 1.0404. Right? It is natural. That number should happen because 1.02 square, right? It is 1.02 square, so 1.0 square is 1.0404, right? Because it is now 2%. 2% every 6 months. Therefore, this one is 0.02 square, right? So it is the same. How about from source time? Okay, then number would be look like this, and this one becomes bigger and bigger and looks like this. Okay? And if we draw a graph, okay, looks like this. Okay, as compounding becomes bigger and bigger, this number should increase because it is natural, right? It is compounding, so we compound more and more. Then interest. We have interest on interest, so this number should increase. But important part is that this number does not increase to the infinite. Okay, there is a limit of this number. The limit is ex, right? So the limit is this number. So in this case, it is 18, so this number is already similar to this one number, right? Even 18 compounding, the number is already become similar. And if we go infinite, like 100, 200 times, so now number is almost the same. So it converges very quickly. 1.0411, and then okay. So this is like several decimal approximation, so it converges very quickly. And if we do to the infinite, then it becomes exactly the same. Okay, so I assume everyone understands the E right now. E is very important. So from now on, when we say interest rate, we usually assume it is continuous compounding. Because it is what industry people use. When industry people says interest rate, at least among quant, we always think in terms of a continuous compounding. If there is not continuous compounding like annual interest rate or monthly or semi-annual interest rate, it is very easy to convert that interest rate to the continuous compound. So anyway, it doesn't matter. We can always convert other compounding to the continuous compounding by taking log, basically. Okay. Anyway, it is the most important one. Okay, now let's go to our topic, today's topic. So we are thinking about the value of a contract that pay $1 when stock price go up and $0 when stock price go down. Scenario 1, they pay $1. In this scenario, they pay $1. In this scenario, they pay 0. So at least we know that the limit, the range of the value of contract is from between 0 and 1. Because in worst case, you receive nothing. In best case, you receive $1. There is possibility of those two cases. Therefore, the value of contract is 0 to 1. In addition, we can make a better contract than this one. A better contract is that is a contract to pay $1 every case. Okay? Definitely, you will prefer the contract to pay $1 in every case than the contract that pays $1 in a specific situation, right? And then if there is a contract that pay $1 in every case, then it is $1 for sure. Certain $1 in 3 months. Therefore, that value of contract we can simply discount it. Okay? And then ER point 0.25. Okay? So now the range is slightly narrower, right? The range of this contract, therefore, from 0 to e to the power of minus r 0 to 5. Okay? So range. But still, it is just range. We want exact number. Right? We want exact number. And what it is. Actually, the answer is, it is like elementary school mathematics. It is very easy to calculate the value. It is just elementary school, but at most middle high school mathematics is very easy. But the idea of getting this concept is so fundamental in finance and derivative, so it deserves Nobel Prize. Anyway, the idea is very simple. The fundamental idea is that in order to know the value of the contract to pay $1 in specific situation, the idea is that we replicate. Basically, we make this contract at home, okay, with other products. It is like finding the value of pizza, right? The idea is that in order to find the value of pizza, idea is that we make pizza in our home, okay? And there is a cost of materials element, right? We need a dough, we need sausages, and we need mozzarella cheese, something like that, right? So there is a cost of making the pizza. So in order to find the value of pizza, basically we can make pizza at home, and then we know how much does it cost. Exactly the same idea. So next, in order to replicate the contract that pays $1 in this scenario, okay, the intuition that we need at least two ingredients to make this pizza, because intuitively we have two situations, right? We have two situations. So mathematically we have two independent states, which means that we need two instruments. Okay? Two instruments to make the pizza. So you can think there is a contract that pay $1 in this scenario and $0 in this scenario. What would be the most obvious first ingredient to replicate this contract? Okay, I told you there are two contracts. What is one contract? We need the two instruments to replicate this contract. So what would be the most obvious, the first ingredient in replicating this one? Do you have any idea? What would be the one? Okay, the idea is that, okay, when stock prices go up, they pay $1. Go down, they pay $0. Right? Therefore, the first natural ingredient basically this stock, right? Because this contract is contingent on the value of stock. Therefore, in order to replicate this contract, we need stock. Oh, by the way, there are a lot of ways to make a contract to pay $1 in this scenario and $0 in this scenario. Okay? In this textbook, they structure that contract using call option. Okay? In the call option is option to buy. Call option is basically right to buy. So option 21, it is right. This is right to buy an asset at $21. Therefore, if we have this call option contract, if stock price becomes $22, okay, we can buy $22 stock by paying just $21. So I make $1 profit, right? So I earn $1. Okay. But when stock price is $18, okay, we are not stupid to pay $21 for a product that value just $18, right? So we basically give up, discard this right, okay? So the value of that contract becomes 0, right? We get away, okay? We trash, get away that contract, right? Okay? So this call option contract basically structure the contingent contract. They pay $1 in this scenario and $0 in this scenario. Anyway, that's not important. We are interested in contract to pay $1 in this scenario, 0 in this scenario. So okay, the idea is that we want to make a contract ourselves that pay $1 here and $0 here. Idea is we need two contracts, but first contract is obviously stock itself. Another contract is basically we need any contract we find basically as far as that contract is independent of the first stock price. But in this case, okay, we use risk-free asset, bank account, as our second element. Okay. So the idea is that in order to replicate a contract that pay $1 in good scenario, in order to replicate that, we will use stock and risk-free asset. Okay, and then we replicate it. So let's think about that one. Any question until now? No, right? No question. Any question, Rory? Is it too difficult? No, not difficult at all, right? It's okay. Okay, please stop me if it is difficult. Is it okay? Not difficult, right? It's too simple, I think. Because this is very simple, but this is fundamental. Once you understand this part, this entire book is just small extension of this idea. That other part is nothing, basically. You don't understand? Okay, so again, let's repeat, okay? Because it deserves repeat, because it is fundamental. If you know this one, okay, this is the only thing you have to know. Okay, out of this entire book, this is the only thing. And if you understand this one, this entire book is just technical extension, nothing. Okay. Again, our goal is to find the price of the contract that pays $1 in this scenario and $0 in this scenario. technology is so advanced. And then aliens teach it wonderful technology to French firms. Then what's going to happen to the stock price of the French firm? Goes up, right? So because of the alien, let's assume the stock price goes up 6,000 in 3 months. Okay? But there is a possibility that alien doesn't visit, right? Now let's I love France. I love France. Okay, I love beautiful city, Paris and Lyon, those places. So I don't want alien destroy the beautiful city. Therefore, let's assume that there is a possibility that alien don't visit. In that case, let's be slightly pessimistic, and then index drop to 4,000. And it's just hypothetical. Again, it is easy to figure out this number and this number. I'll teach you how to get it. It's alien is still case, but we can generate more realistic numbers later. That is not difficult. Okay, there are two possibilities. So, right, it goes up to 6,000 and drop to 4,000, right? Category. And then suppose Rory want to develop a contract such that, okay, I want to make a betting on the alien visit. Okay, so if alien visit France, I'll pay $100. It is like a gamble between friends, right? In 3 months, if alien comes to Paris, I'll give you $100. And if alien doesn't visit, then I'll pay nothing. Okay? Then the question is, okay, so Rory wants to sell that contract to Minji. Okay, you pay $100 when alien visit, and $0 when alien don't visit. Then the question is, how much Minji has to pay to you? Okay? How much will you pay? It's a betting between friends, right? So if we go back to previous example, the answer should be between $0 and $100, right? It should be greater than 0 because in worst case you need nothing. So if Rory promised you that she will pay you $100 if alien visit, then definitely you should give some money to Rory, not receive money from Rory, right? So the value of contract should be greater than 0. But the value of contract should be less than $100 because there is possibility that aliens don't visit France. So the value of this contract is from 0 to 100. But that's the, and in addition, okay, we can make another contract that Rory pays you $100 in every case 3 months later. Then it is $100 for sure. So the value of that contract is discounted price of that $100, right? So anyway, the value of the money that you have to pay to Rory is between 0 to the discount of the $100, right? But again, we need some exact number. Okay. So in order to calculate how much Minji has to pay to Rory, okay, our idea is that, okay, because we replicate this contract with other assets. Okay? Because we don't know directly what would be the price of this contract paying $100 when alien visit. We don't know that directly. Therefore, okay, even though we don't know this contract directly, we may be able to create the contract ourselves with known asset, and then find the value of that asset. We don't know the price of the pizza. In that case, we make pizza ourselves. Okay, that's the idea. Okay. So, pizza ingredient 1 is French contract because it is contingent. It is contingent on alien visit, but basically it is contingent on stock price too. Right? When stock price hit $6,000, you pay $100. Stock price hit $4,000, you hit zero, right? So it is alien visit, but basically it is betting on stock price, right? So when stock price hit 6,000, you pay $100. Stock price hit zero, you pay nothing, right? So although it is alien visit is real, so it is betting on stock price. So basically, since it is betting on stock price, in order to replicate this betting, we use stock price. Another second ingredient is we can basically use anything. So for simplicity, we use risk-free assets. French government bond. So idea is that we use French stock market and French government bond in order to replicate a contract that pays $100. We pay the stock price $6,000, right? Any question until now? No question, right? Okay. So let's calculate the value of this contract. What is the contract that pay $100 AUB or $100 if stock price hit 6,000? I told you we need two ingredients to make this pizza. So our question is, what is the value of contract that pay $100? First, let's invest X dollar in stock market. If we invest X dollar, actually it's French X euro, right? Okay, let's say it's X euro. If we invest X euro in French stock market, what would happen in 3 months later? No, there is no E in this case. If you invest €1 in French stock market, what would happen in 3 months later? Stock price can go either up or down. Yeah, but there is two possibilities, right? You can make either make money or lose money. Okay, if you make money, how much money will you make? If you invest €1. Okay, if stock price go up, it go up from 4,379 to 6,000. So if you invest €1, if stock price go up, you will make 6,000 over 4,079, right? Yeah, something like that. Okay. But there is unfortunate case that alien don't visit and stock price go down. In this case, if you invest €1, your money becomes 4,000 over 3,279, right? So if you invest $1, €1, it becomes either you go up, which is 6,000 over, or it go down, and right? If you invest $1, your €1. If you invest €1, your €1 become either this one or this one. If you invest X euro, your money become either this one or this one. But if you invest X dollar, if alien visit, your money become X multiplied by U, right? If there is no alien visit and stock price become 4,000, then your money, if you invest X euro, then your money will be XD, right? Because for every €1, you becomes UOD. So if therefore invest X euro, it becomes either XU or XD. Right? Now, what if you invest Y euro in French government bond? If interest rate is R, what would happen to it? Yes. Because they pay interest, R falls, the French government doesn't default, right? Let's say interest rate is R, and they pay in 3 months later E R delta T. Here delta T is 3 months. And then if there is no alien visit, still they have to pay this one also, right? So every $1 you invest in French government bond, then that €1 becomes this one, whether alien visit or not. Because you invest €Y in French government bond, it becomes this one, right? Okay, so therefore, if you invest X dollar in stock market, X euro in stock market, and Y euro in French government bond, therefore your portfolio is this one. Right? So therefore, when alien visit or when stock price hit 6,000, your money, since you invest X euro in stock market, Y euro in government bond, your money becomes X U plus Y E R D T, right? And if there is no alien visit, if stock price down 4,000, then your money becomes Y D plus this one, right? Any question? 질문 있어요, 질문? Right? Any question? I mean, you don't have to write it down, but anyway, any question? Okay. Okay, so any question? Second investment, okay. So it is basically this one. This one is similar to E R delta T is similar to 1 plus R delta T, okay. Approximately this one. It means that since interest R is delta T times later, so for every €1, if you invest in French government bond, it becomes this number in delta T times later, right? You don't have to think about the worst case. It is French government bond. They don't default. They pay exactly same amount, whatever happens. They keep their terms, right? So let's assume French government don't default because of alien, okay? It is like a bank. If you put €1 into bank, you receive exact same amount, whatever happens 1 month later. So whether there is alien visit or not, you receive exactly same money. But of course, if in stock market, there are two cases. Now our goal is we combine stock market and bond market in order to create this contract. Therefore, in this contract, okay, in this alien contract, the contract says that when alien visit, Rory pays €100. When alien don't visit, they pay €0, right? Wait, then now problem becomes very simple. When alien visit, my portfolio becomes X U plus Y this part. When alien don't visit, my account is XD plus this one. And I know every number except X and Y. So if I adjust X and Y in some way such that this number becomes 100 and this number becomes 0, then we know the value of the contract, right? Basically, this is the two equation. This one plus this one becomes this one, and one plus this one becomes this one. We have two equations, and we have two unknowns, right? We have to determine x, y. Two equations, two unknowns. So we can solve this problem, right? We can get x and y, right? Two equations, two unknowns. Next, suppose it is very easy to solve this one, right? Because it is a simple, very simple two equations, right? Because this one and this one is same. So if we subtract this one and this one, subtract this one from this one, then it is 100 and this term cancels out. So it is x u minus d, right? So divide each side with u minus d, we can get x, right? Once we get x, we plug that x over here, then we can get y, right? Yeah, what is the question? Please ask to me. Yeah, please ask to me. From the low risk contract, and you wanna create low risk contract yourself using French stock market and French government. That's the point. That's the most important part. So it is a two equation, two unknowns. It's easy to solve. If we subtract second equation from first equation, then it is the second part, y part disappear. So x u minus d equals 100. So x equals 100 divided u minus d. Done. We plug that x over here, then we get y. Done. So easy, right? So basically, I want clean blackboard, so let's use slight matrix notation. So it is like let's write down this one as R. Okay, this is like looks nasty. So R, and then D, and this one is again R, and X, Y equals 100 and 0, right? It's two equation, two unknowns, so we can write down in matrix notation, right? This R is simply this unknown part. Okay? So we can calculate x and y, right? X and y is simply inverse of this one, right? We can calculate x and y. Okay. Now it is very easy to calculate this. So now suppose we know what is x and y. Then what would be the value of the contract that pays $100, 100 euro, if stock price is $6? What would be the value of the contract? Suppose we calculate that metric value, then we can calculate x and y. Then what? If we know x and y, then what would be the value of that contract? If we know x and y, then what we have to do later? That's point is that if we calculate that one, which means that if we invest x dollar in stock market and y dollar in French government bond, that money becomes exactly $100 if alien visit, 0 if alien don't visit, right? We exactly replicate the low risk contract by investing $100 in stock, investing x dollar and investing we exactly replicate low risk contract by investing x euro in stock market and y euro in bond market. Then what would be the value of low risk contract? Huh? What did you say? It is x plus y, right? You invest x euro in stock market and y euro in bond market. So in total, you invest x plus y to portfolios, right? And by investing x plus y, you exactly create low risk contract. contract. Therefore, the value of a low risk contract should be x plus y. Right? If low risk contract is more expensive than x plus y, what will happen? No one will buy low risk contract because I create exactly the same contract by investing x plus y. And please don't buy the contract from Roy. Please take contract from me. Right? Because I create low risk contract with cheaper money by x plus y. If low risk contract is cheaper than x plus y, what's going to happen? Then everyone will want to buy low risk contract. In addition to that, low risk contract and then create contract wholesale for himself. Right? Then we have exactly opposite position, so I can get the profit or the gap between them every possible way. So if Lori sell that kind of contract, I will buy infinite amount of that contract from Lori. And in the market, I sell exactly the same contract with cheaper money by using just the XOL, and I invest the same contract to everyone. Okay, buy Lori and sell. Then because Lori sells that contract in higher price, so I can get the small money in every contract, so I can get infinite amount of money. Right? So therefore, Lori's contract is exactly x plus y. Then let's calculate what would be x plus y. And then one interesting part is that in order to create this contract, we invest around 220 euro for stock, and actually around minus 200 euro for bond. So basically, we are borrowing money. Oh, by the way, please hand in your homework. So Lori, if your homework doesn't work, this is the solution. So why don't you take a picture of this one? Compare your code with it.
I did that.
And then this part.
I didn't understand.
Yes.
I didn't understand how we make this thing. I have to write something here, or?
Yeah. You have to write. You have to set working directory and source your file name.
Oh,
then
I have to do that.
yeah. Here, then this will run your program.
Oh, okay.
Yeah. So if you did, you can take a picture of it. Yeah. So anyway, you can compare your answer with this. Yeah. But anyway, yeah. So question: you invest 220 euro in stock market. But actually, you invest minus $200 in French covered bond. You cannot invest minus dollar, right? Which means that you basically borrow, right? So it means that, yeah, you are taking pictures, or actually you can keep it. Why don't you keep it? Yeah, please keep it. Yeah, it is 중요한 homework, and I just check it is right. So just keep it. If you have a further question, ask him, okay? Yeah, homework. Thank you. So question is, yeah, homework. So in order to make this contract, so basically the nature of this contract, pay $100. The nature of this contract is that invest in stock market and borrow money, right? So it is basically called leveraged position. You have to take leverage, right? Because you borrow money. That's why some people call call option as a leveraged position. That's the intuition. In order to create call option like that contract, you have to borrow money. So investing in call option or investing in this kind of low risk contract is basically borrowing money. Investing stock market by borrowing money, with borrowing money. That's why option is called leveraged position. Call option is leveraged. That's the intuition. And let's do some experiment then. Okay. Question number 1. If I increase this number, okay? So if stock price, if alien visit, in good scenario, we assume stock price becomes 6,000. If I make that one like 7,000, what's going to happen to the value of the contract? Increase? Increase what? Yeah. So if I increase that, you increase, and this will increase. So therefore, okay. Okay, raise your hand if you think if I increase. So if alien visit, now they give us even better technology. Okay. Now instead of 6,000, it becomes 7,000, right? In that case, will low-risk contract value contract now will be more expensive or cheaper? Raise your hand if this one become more expensive or this number become higher. Okay, majority. Okay, raise your hand if you think this one become lower. No, you why? There is no competition between them. Okay, it is kind of competition, a perfect substitute. Anyway, let's do 7,000 and up going down, right? Not going up. Why is that? Why? You know, I always say mathematics is not important in doing finance. Okay, storytelling is more important. Understand intuition. Okay, so of course mathematically, if we do the calculation in matrix algebra, if value increase, this one should decrease. Mathematically straightforward, but that's not important at all. You have to understand why this one goes down. Can anyone give me an idea? Definitely, we become happier before that. Okay, but what's the value of growth starting to go? Why is that? Yeah. Increase. Okay, so if you think this gap between the two increase, this one going down. Okay, so let's increase the gap by reducing the value. So let's more dismal scenario for French stock market. Let's say it's 2,000. If it is become 2,000, should we become higher or lower? Raise your hand if it should become higher. Raise your hand if number should become lower. You said okay, higher. Okay. Why is that? So let's do it one by one. If it becomes 7,000, why? You know, option contract, value of option contract should increase. It's volatile increase, right? So I'm sorry. This is not correct interpretation. Okay. I'll give you the answer. The answer hint is over here. This one, current stock price. I didn't change current stock price. Even if the good scenario generate higher payoff from 6,000 to 700, higher payoff, I didn't change current stock price. Imagine, okay, low risk contract pay stock price variation is, if the probability that we receive money is high, then low risk contract should be more valuable, right? Okay, if we have a high chance of getting 100, right, the value of this contract should go up, right? If we have a low chance of getting this one, value of this contract should go down, right? That's natural. Now imagine that one. Now the payoff on the good scenario went up, but today's stock price didn't change, which means that doesn't make sense in some sense, right? If alien gives likelihood that alien gives us a better technology, then current stock price should go up, right? That makes sense. But I didn't change current stock price and only increase the payoff on the good scenario, which means that therefore, in order to make current stock price remain same, it should be the case that probability of alien visit should be lower, right? That's why I increased the payoff for that case, and the current stock price didn't change, right? So either probability go down, right? Probability should go down, right? If probability remains same, we have received a high payoff on the good scenario, current stock price should go up, right? But I didn't change, which means that the probability of alien visit or stock price going up should be low. Therefore, it means that receiving money from Rory is less likely. Therefore, value of Rory's contract should drop. Right? We can apply exact same argument. I change bad scenario, right? Bad scenario, and if we increase the bad scenario, if we decrease bad scenario, right, 3,000, it means that low risk contract goes up because even though the bad scenario is less profitable, but today's stock price didn't change, which means that bad scenario is less likely, which means that good scenario is more likely. By the way, in good scenario, we receive money from Rory. Since we have more likely, it is more likely that we receive money from Rory. So Rory should sell contract at high price. Right? It perfectly makes sense, right? Next question. What if French central bank, not French central bank, okay, Euro central bank, Draghi, okay, President Draghi of ECB, rate interest rate. Current interest 2%. What if interest rate is 5%? Will the value of contract go up, go down? Raise your hand if it goes up. Raise your hand if it goes down. No? Well, how do you think? How do you think? No mathematics, just use your imagination. What if President Draghi raise interest rate in euro rand? Okay, let's see that. Let's say that President Draghi raised interest to 5%. Wow, low risk contract is more valuable now. So low risk contract become more valuable if interest rate went up. Why? Why is that? Hint is this one. Minus number. You have to borrow money. Okay? You have to borrow money in order to create this contract. The answer is that basically this contract is leveraged contract, right? So investing in this low risk contract or call option, investing in call option is economically borrowing money, investing stock market. But now interest rate goes up, so it is more costly to borrow money. it becomes more expensive to create low-risk pizza. So value of low-risk pizza should go up. Alternatively, if interest goes up, still since it's a leveraged contract, in order to create low-risk contract at home, you have to pay high money. But if you buy a low-risk contract, you don't have to pay that financing cost. Therefore, since you don't have to borrow money to make this contract by simply investing low-risk contract, it saves you financing cost. Therefore, if financing cost goes up, low-risk contract becomes more value because there is more demand. Because you can save financing cost. You don't have to go to the bank. Okay? In order to create this contract at home, you have to go bank now and have to pay higher interest rate in borrowing rate. Interest rate goes back to this country should go. Makes sense, right? Any question? You know that this is the fundamental of this simple elementary school mathematics, but this is the fundamental of derivative pricing. In order to get the price of derivative, you replicate derivative using other assets. You create replicating portfolio, and then the value of replicating portfolio is the value of derivative. Simple, right? It is two unknown parameter and two systems of equation. This is the fundamental idea of derivative pricing, and we have fancy method replicating portfolio, option pricing by replicating portfolio. And let's go to textbook example. Textbook example is the current stock price is 20, no option on this contract. Stock price is 22, option price 1. So call option stock price is 21. So if stock price is $22, I pay only $21, so I receive $1. If code 81, I don't wanna pay $21 for $80 stock, I pay nothing. So option price is 0 basically. So pay of $1 0. So I can use the same Excel sheet. So now current stock price is 20, and on the good scenario it is 22. It is 18, right? 18, and then pay $1. So in this contract, the value of this one should be about 0.5. Of course, I have to change interest rate, but right, simple. Any question? I can simply change the number. If we wanna create contracts that pay $100 in this case, then it is simple. We can buy this contract 100 times of this contract. So value of contract is simply multiply by 100. Again, in this contract, I pay $1 in good scenario, right? If I wanna create contract that pay $1,000, $10,000 in good scenario, answer is same. I can multiply 1,000 to this one just, right? Same, right? Because this contract, as far as we know, the value of contract that just pay $1 in good scenario, like $10, $100. Other contract is simply we buy multiple contracts. Okay? We can buy 100 contracts from Lori. This contract is exactly the same contract that has pay $100. What if Lori pays 0? Now we can think of put option, right? Put option and Lori pays $1 in bad scenario. Then this value is about 0.43 cents. It is called put option. They pay money in bad scenario. Okay. This is my way of doing derivative pricing. So my idea is that I create derivative, put option, whatever. I create derivative by creating portfolio of stock and bond, and check how much I invest in stock and bond. I can calculate the value of derivative. In the textbook, actually they use different way, slightly mathematically equivalent, but in the textbook they have a slightly different way of computing the derivative. In our previous lecture, in this lecture, we basically our target is derivative. We use stock and bond and match the target derivative. But in the textbook, it is slightly different way. In the textbook, target is risk-free asset. So in the textbook, they use now call option or derivative and stock in order to create risk-free asset. So we have three assets, right? We have a derivative, we have a stock, we have a bond. So in my method, I use stock and bond to create this derivative. But in the textbook, they use stock, derivative and stock to create this risk-free asset. Of course, the third method is we can use derivative and risk-free asset to replicate stock. We have three assets, so we have using two ways can replicate other one. Okay? So we have three ways of doing it. They are all mathematically same. It's a different way of setting up systems of equation. So that's your homework. Okay? Homework. Almost all textbooks use this way, replicate risk-free asset. So anyway, call option. A 3-month call option on stock has a strike price 21. So when stock price $22, strike price 21, so I make $1. So option price 1. When stock price $18, I don't want to pay $21 for $18 contract, so I don't exercise. So X option is useless, so option price 0. So my question is, what would be the option price? Basically, the value of call option price, which is basically paying $1 in good scenario. In the textbook, they are setting up a riskless portfolio. Okay, so it creates a portfolio, a long portfolio that is long on delta shares. Okay, so they buy delta shares. So in my example, I think everything in terms of euro amount or money, dollar amount. But in this case, they use everything in the unit of the stock. Anyway, mathematically equivalent. Anyway, for a portfolio, they buy delta amount of shares and they sell one call option. Okay, one stock. Then because they sold this option. In good scenario, I have to pay $1, and by the I pay nothing. And then I invest delta amount in stock. Therefore, my portfolio is when stock prices go up to $22, since I have a delta amount of stock, my value of my stock is 22 multiplied delta. But since I sold the call option, I have to pay $1. So my payoff is this one. And when stock price go down, even though I sold the option, okay, I pay nothing, but my stock price is 18. Okay, so I have a delta number of shares. Therefore, my position value of my position 18 delta. Okay, so two scenario, two portfolio value, 22 delta minus 1, 18 delta. Okay, then if I set this one equal to each other, 22 delta minus 1, 18 delta, then my portfolio is riskless, right? If this and this is the same, it is the portfolio pays exactly same amount whatever happens. I receive same amount whatever happens. Therefore, it is riskless portfolio. Okay. So to make this one equal to this one, and 22 delta minus 1 equal 18 delta. It is one equation, one unknown. So we can solve it, right? Delta is 1/4. Therefore, if I buy 1/4 of the stock and I sell, okay, I sell option, value of my portfolio is 4.5, right? 4.5. 18 multiplied by this one, or this one is 0.45. So value of my portfolio becomes 0.45, whatever happens. Okay? And it is easy to calculate the value of the portfolio that pays 0.45, whatever happens, right? We can simply discount it back. So the riskless portfolio is I take long of the 1/4 of the shares. I short 1 call option. The value of portfolio in 3 months is 22 multiplied 0.5 is 4.5, right? 4.5. So whatever happens, I receive 4.5 in 3 months. And then here risk-free rate is 22%. Okay, so 12%. So in 3 months, so I discount it back. Then value of basically portfolio is 4.36. The value of the contract that pays $4.5, whatever happens, is $4.3670. Okay? So the value of the contract that buy delta unit of shares and one short position in call option is exactly $4.3670. And I know the stock price. I don't know the bond price. I don't know the derivative price. But I don't know the sum of these two positions. Therefore, I can know the derivative price, call option price. Right? So in the textbook method is I solved two equations, two unknown problems at once. In the textbook problem, they divided this one into the one equation, one known parameter problem 2 times, right? So mathematically safe. Okay. Now the portfolio that is we buy 0.25 shares and short one option is worth $4.367. By the way, the value of the share is currently stock price is $20, and I need a quarter of the share, which is $5. Okay, so therefore the value of option is option value plus short position plus $5 is 4.367, right? Therefore option position should be 0.633, right? That's why I have to add this one and this one to get this number, right? Because I take long position of this one and short position of stock, and we know the worth is this one. So basically it's one equation, one known parameter problem. So value of the option is 0.633. Let's check it. So now interest is 12%. Okay, $1 and 0. Exactly same. 0.633. Okay, so we have to round up, then number is exactly the same. 0. So therefore the value of option is 0.633. Simple, right? So the idea is, okay, we combine stock and derivative, create riskless position. So which means that we pay exactly the same amount whatever happens. So we discount it back. Then we know the value of replicating portfolio. We know the sum, but we don't know the derivative price. But we know stock price. Therefore, since we know the sum, we can know the derivative price. Sum is $4.367. The stock is $5. Therefore, the gap is 0.633. It should be the option price. Right? Simple. Any question? I think my method is better than this one, right? I taught this one to the MBA student, and MBA student said that they prefer textbook method. This method is simpler than my method. Anyway, question? R? No, you whatever. Oh, by the way, I said R is also good. So just create R. You know, I made the program with Excel, right? You can simply check that Excel to R. Okay, very easy. Okay. You know, you already know the answer, right? You can just copy that Excel file in your USB and create the Excel file to R. Re-engineer that to R. Of course, you will need a matrix algebra with R, but you can Google it, R matrix. And then any question? You know, textbook method is also simple, right? So again, we can go to the again, textbook method is creating, replicating risk-free Excel. My method is will replicate derivative. Third method is replicating the stock. Okay, do that homework. That would be a good exercise. Okay, the valuing the option. Now we can generalize. Okay, generalize. Okay, so they use the same thing U and D. Okay, a derivative rest for time t. I think this is the good place to stop basically. I think today we learned the most important part of the derivative type. So I don't want to go to this step and confuse you. Okay, so let's stop the today's class at this point. Okay. Any question about today's topic? Perfectly understand this one. And is everything clear about next week homework? What do you have to do? What do you mean by homework one is what? I know that. R and whatever first or second, whatever method. Okay, so basically I taught you two methods of derivative price. When you create R program, whatever. Third method is your homework, and again you can create R program for your third method. You can just pick one method for R program. 야, 또 질문 없어 질문? 하나도 안 어렵지. 이것만 알면 데리바티브 프라이스는 더 이상 없어요. 그냥 숙제는 바꿀 수 있게. 코드를 제출하면 저는 이해가 안 된다. 또 질문 있어요, 질문? So for your first homework, of course you can use Excel, but please write down, do it by hand. Okay, it's a bunch of equations like this. So I think it is more educational to actually write down the equation rather than program. So first homework is by hand, second homework is by R. 변수를 한번 정의하면 그 변수를 계속 참조할 수 있으니까 더 편한 거죠. 아니, 그러니까 참조되는 식의 이퀘이션들이 연결돼 그거 그대로 쓰면 되지. 그렇지. 그래서 맨 나중에 구하고 싶은 거만 해도 그렇게 생각. 질문 없어요? 네, no question. Okay, well, thank you for today's class, and let's stop the class at this point.